Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today inscribed angles. These are angles in a circle whose vertex is on the circle and formed by two chords of the circle. Now, we shall see the problem set about inscribed angles. Okay, over here, we have the inscribed angles. These are lecture examples, and we will be using about how many? We will be having about 18 numbers. Yes, 18 numbers. All right, so we shall be solving one by one starting from the first, and we'll be using one problem per screen. So here's the first one. Find the measure of the angle indicated. Now, first we shall have a little definition of the inscribed angle. In this particular figure, you'll be able to check on the inscribed angle. There are about three, okay? All right. We have the angle KFM, okay, over here, there, that angle. So you will notice the vertex at point F and the chords FK and FM. So this is an inscribed angle. Another one is MF, involving MF chord and ML chord, okay? And this is the unknown inscribed angle, okay? The unknown. And we're after the measurement, okay? And that's another inscribed angle. Another is the angle MLK. You can see the angle MLK, and it's supposed to be with side ML and side LK. And here's the other side there. And so the angle MLK is this. So there are three inscribed angles there. So the definition of inscribed angle is an angle in a circle formed by two chords and whose vertex is on the circle. Okay. Now, some basic definition, like the measurement of the inscribed angle is 1/2 of the central angle subtending the same arc. Okay. Now, what do we mean by that? If we have a circle like this, and we have this particular inscribed angle there. Now, there's the central angle over here, there. If this is A, if this is A, then the measure of this is 2A. There. Okay. So the two angles subtends the same arc. Okay. This particular arc. And so the measure of the arc is the same as the measure of the central angle 2A. So 1/2 of 2A is A. And that's the measure of the inscribed angle. Take note, they subtend the same arc, okay? There. So the inscribed angle and the central angle subtend the same arc, okay? All right, so 1/2 of the arc is the measure of the inscribed angle. All right, and so that'll be a little concept about the inscribed angle. Now, going back to the problem, we're asked to find the measure of the angle indicated. All right, so the way to get this, we have this particular angle here, and this is the required angle. If only we can get this arc, then we shall divide by 2. That measurement shall be divided by 2. And that will be the measure of the angle with a question mark, okay? Because it's 1/2 of the arc, the subtended arc will be the measure of the inscribed angle at M, okay, or FML, okay. And so we have here 80, and we have 80, and then if we go around that arc, okay, we have one full circle. So that means to get the arc FKL, which we need, okay, the measure of the arc, okay, FKL. All right, one half of that, if we divide that by 2, that gives us the measure of the inscribed angle FML, which is the one with a question mark, okay? All right, so if we go around the circle, then we have the measure of arc LM plus the measure of arc MF, okay, plus the measure of the bigger arc FKL, FKL must be equal to one full circle, 360. There, okay? All right, let's put the given. Arc LM is 80. Arc MF is 80 also. Okay, the remaining arc FKL is what we need. FKL. And this equates to one full circle, 360. So 80 plus 80 is 160, plus the measure of FKL is equal to 360. Now we subtract 160 from both sides, and we shall have the measure of arc FKL, and this must be about 200 degrees. Okay, now going back here, all right, we're asked to get the measure of the angle, the inscribed angle FML, okay, which is one half of arc FKL. All right, so we shall now use it now. We have here the measure of the angle FML, the angle with a question mark, is equal to arc FKL, which is 200. Okay, this is FKL divided by 2. So this is 200 divided by 2. And this is just 100 degrees. Okay, that's the answer. Okay, so I hope you were able to follow that particular solution. Okay, and so the answer is 100 for the angle with a question mark. Okay, all right, so a little explanation. It's because this arc here measures 200. Yeah, so one half of the subtended arc will be the measure of the inscribed angle. So the angle with the question mark is, or measures 100. Okay, let's check the answer from the computer. There you are. Be able to check it near the diagram there. So this must be correct. Okay, all right. Next, we shall do the next problem, number 2. Let me clear the screen. Proceed to the number 2. Here's number 2. Find the measure of the angle indicated. All right, we're looking for this angle here. There. Okay, so if only we can get the arc over here. Notice the angle in question. Okay, this inscribed angle here. There. that will be 1/2, okay? That will be 1/2 of arc XCD, okay? This arc here, if you go around like this, okay? 1/2 of that, 1/2 of that arc will be the measure of the angle with a question mark, okay? All right, so we shall get arc CD first, arc CD. All right, so how can we get arc CD? All right, let me compute that. We have arc DE, that's 60. We have arc EX, that's 128. And then the remaining arc will be a portion of the circle, which is one full circle, 360. So in our equation, DE is arc, EX is arc, and XCD is the remaining arc. Okay, so if we can only get that, then we'll be able to solve the angle with a question mark. All right, so this is how we solve it. Our working equation will be starting from arc DE plus the measure of the next arc, that's EX, plus the measure of the larger arc XCD. Okay, that's one full circle. Okay, that will be one full circle. All right, and so this will be equal to 360. All right, let's put the given arc DE is 60, arc EX is 128. There. All right, and so we are solving first for arc XCD. And this equates to 360. All right, the sum of 60 and 128 is 188 plus measure of the arc XCD is equal to 360. We shall now subtract 188 from both sides. Subtract from both sides, we have the measure of arc XCD now. And this is equal to, this is 2 and 7, 172, okay? Yes, all right. So we can now use the arc XCD, which is the subtended arc by the required inscribed angle. All right, and so we have this formula. The angle with a question mark, all right, is equal to the measure, or the measure of the angle with a question mark is equal to the measure of angle XED there, which is equal to 1/2, 1/2 of the arc XCD there. And so this is just 1/2 of 172. So we shall just divide this. All right, so this will be about, how much is half of this? This will be 36 and 50. That should be 36 and 50. That looks like 86. Okay, yes. So this will be 86 degrees. The measure of the angle with a question mark there. Okay. All right. So let us check the answer. All right. So over here, check and see below the diagram. Okay. That is the usual location of the answer displayed by the computer. All right. So is that 86? Yes. All right. There. So our answer over here is correct. There, 86 degrees. All right, let's continue with the third. Let me clear the screen. Proceed to the third question, third diagram. All right, here. Find the measure of the angle indicated. All right, find the measure of the angle indicated. All right, so if only we have the arc XWK, then we will be able to solve for the inscribed angle with a question mark. Okay, this angle here. All right, take note of the inscribed angle. Supposed to be this. All right, there. Okay, the one with the question mark. Now, if only we have this arc here, then if we have that measurement, we will add the 62, after which the total will be divided by 2, and we shall be able to compute for the unknown. Okay, all right, so first, we shall consider the 105 inscribed angle, this one. Okay, and twice of this inscribed angle will be arc WKY. Okay, WKY. All right, so that means that's 210. Okay, 210. So the measure here is 210. There. Okay, the big arc here is 210. Now, if we subtract the 62, then we'll be able to get that part, or we can go around the circle at this point. Okay, we can go around the circle at this point. 80 and 210 plus arc WX will be 360. All right, that's another way of doing it. Now let's use that because it's easier. All right, the measure of arc, we will start with the unknown arc WX. All right, and then add the arc XY, the measure of the arc XY. There. Also, we now have the bigger arc YKW or WKY. Okay, that's the measure of WKY, which completes our 361 full circle there. All right, so let's go around it once more. WX, the measure of the arc WX, which is the unknown, plus the measure of XY, which is given at 80 degrees, plus the measure of WKY, which we computed, that's double of 105, that's 210. That completes the circle, which is equivalent to 360. Okay, all right, so we shall combine like terms. 80 and 210, that's 290. And this is to be added to the unknown arc WX. And this is equal to one full circle, 360. Okay, subtraction property, minus 290, minus 290. We have our arc WX must be equal to, how much is this? 70. Yes, that's 70. All right. And so we now have arc WX at 70. Okay. Now, the sum of arc WX, all right, the sum of arc WX plus, all right, the other arc WK, all right, the sum of this will be the subtended arc of the required angle, okay? All right, and so the sum of these two arcs divided by 2 will be the measure of angle XYK, the angle with a question mark, the inscribed angle. So this is equivalent to, let's put a name on that, that's angle XYK, XYK, there. This is the angle with a question mark, the inscribed angle. So if we put the values now, we have WX arc, that's 70, and we have WK arc, the 62, and then the sum is divided by 2. This is 132 we divide this by 2. So we have, how much is that? 66. Is that 66? All right. So yes. All right. So the measure of the angle with a question mark, and that's equal to the measure of the angle XYK is equal to 66 degrees. All right. Let's check and verify. Watch the answer below the diagram. There. Okay. All right. And so that's it over there. That's the answer. And that's our answer also. That means it's correct. Let's proceed to number 4. All right. Let's proceed to number 4. Let me clear the screen. Let's continue with the next diagram. Solve for x. Okay. This time we're only after the x. All right. Looking at the diagram, we can solve for x if we will find, okay, the measure of the arc MLZ, okay, because that's the subtended arc, okay. I'm talking about this angle, all right. That angle subtends this arc there, okay. So if we can only get that measurement and divide it by 2, we can equate half of that to 7x plus 23, okay. Half of the arc will be equated to this angle, okay. Remember, that's the arc. One half of that is the measure of the inscribed angle. And so we shall get first that big arc there, okay. That big arc. All right, so let me clear that arc first. All right, and we shall call that arc arc MLZ. The measure of arc MLZ there. All right, so how do we get that? We shall go around the circle again, and we will have to get arc LZN first, this arc there. And that is 2 times 65, okay? And that will be 130, okay? This arc that I made is 130, this arc, okay? That's 130. So if that arc is 130, we will subtract the 68. So if we have 130, we subtract the 68, we're going to have how much? 62. Okay. All right. So that will be 62. So the measure of arc NZ is 62 here. There. Okay. All right. Now we can go around the circle now. Okay. We shall go around the circle, and okay, at this point, we can make use of, yes, it looks like we have 68, 62, and 70 plus arc ML, okay, arc ML, that completes the circle. And we have a simpler solution, and we don't need a 62 after all. It's 130 plus 70 plus ML. I figured that out. So that means we can compute for arc ML without the 62, right? Yeah, because the 70 is already the arc. And so we will just use a simpler solution, arc ML, okay, plus the 130, which is our arc LZN, LZN, there. And then plus the arc MN, that's already one full circle, 360. This will be an easier solution, okay? ML, which is this, all right, plus 130 plus the 70 is already one full circle. So this will be ML, that's the unknown, plus LZN, that's 130, and we don't need a 62, okay? So this is 130. This will be shorter. And then plus the other given arc MN over here, That's 70. And this equates to one full circle, 360 there. Okay, so this gives us 130 and 70, that's 200. And this is added to the unknown ML. And this is equal to 360. And so we subtract 200 from both sides. And we have now the measure of the arc, ML, there. And this is just, how much is this? 160. So we're looking for arc ML, which is 160. There. Now, we can now combine 160 and 68, all right? The 160 and the 68, and then dividing that will be, dividing that by 2, that will be equivalent to the inscribed angle 7x plus 23, and we can have that equation. And so this is now our working equation. Arc ML plus arc LZ there, and then half of this is equal to the angle MNZ, okay, equal to the angle or the measure of the angle MNZ, MNZ, and this is our working formula. Okay, let me clear up my scratch there. Okay, this will be our next portion. We shall now use this formula. So we have here the 160 for arc ML plus arc LZ, that's 68. And then half of this will be equated to the equivalent of the angle MNZ, which is 7x plus 23. 7x plus 23 there. All right, so let's combine this. This will be 8, 12, and 2, okay? And this is to be divided by 2, which equates to 7x plus 23. All right, so this divided by 2 is 114 equals 7x plus 23. Subtract now 23 from both sides. This will be 1 and 91. We have 7x. And so we divide both sides by 7. Divide this by 7 and divide this by 7. And that should be about, how much is that? That'll be 13. X equals 13. 21 and 2. Yes, x equals 13. Yes, that's the answer. X equals 13. All right, so let us check and verify. Look at the diagram. It must be close to the diagram, okay? There, okay, you can see the answer. There is the answer. It's 100, it's 13. Yes, 13. So that would be for the value of x. That goes to our number 4, okay? I hope you were able to follow the solution. All right, so that goes to our number 4. Let's continue with number 5. Let me clear the screen. You can rewind the video later to verify. All right, so let me clear the screen. Our answer for number 4, x is equal to 13. All right, clear? Then continue with number 5. All right, here's number 5 diagram. All right, let's see the diagram first and do a little analysis about the diagram. All right, we can see a diameter, okay? Diameter creates half circle, okay? That means this is half circle there. And we have the arc over here. This arc plus this arc is equivalent to 180, okay? Half circle, okay? Remember, one full circle is 360, half circle is 180. And so the measure of the two arcs added together will be 180. So our working equation will be The measure of arc EF plus the measure of arc FG must be half circle with a measure of 180 degrees. There. All right, these are expressions, so we will have to solve for x. Okay, arc EF is 6x. Arc FG is 5x plus 15. 5x plus 15, and this is equal to 180. All right, so 6x and 5x is 11x plus 15 is equal to 180. We subtract 15 from both sides. This gives us 11x equivalent to 165. There. Yes, 165. Then we divide this by 11. 11x is equal to 165. We proceed by dividing both sides by 11. X is equal to, how much is that? 1 and 5. Yes. 1, 5 and 1, 5 is 165. Yes, that's correct. So x is equal to 15. And that should be the required answer, okay? All right, let's check and verify what's the value of x. Check below the diagram because the computer displays the answer just below the diagram. There, okay? And there's the answer. And we're done with number 5. Let's proceed to number 6. Let me clear the screen. Proceed to number 6. All right, here's number 6. We have another diameter over here. That means we have another half circle. We can make use of 180. Also, we can make use of, all right, the 3x plus 3, that's the angle, that's the inscribed angle, okay? And 7x minus 8 looks like the subtended arc, okay? All right, let's figure out our equation here. I think we don't need the diameter, okay? We don't need that part. All right, so we can simply equate. Yes, we can simply equate. Looking at the inscribed angle, this is the inscribed angle, so that 1/2 of this arc is the measure of the inscribed angle, okay? And we have something like this. The inscribed angle, which has a name GEF, the angle, the inscribed angle, is equal to 1/2 of the arc. 1/2 of the measure of the arc GF. There, okay? So we can form our equation. The angle GEF is 3x plus 3. And this is 1/2 of the arc GF, okay? And this is 1/2 of 7x minus 8. There. Okay, let's simplify the equation and solve for x, okay? The requirement, solve for x. So we multiply both sides by 2. So we have 3x plus 3. This is 1/2 of 7x minus 8. Let's get rid of that 1/2. Times 2 here, times 2 here, okay? And the 2 cancels out. We only now have 6x plus 6 is equal to 7x minus 8. There. And so we subtract the 6x from both sides, and we have the left side 6. We have the right side just x minus 8. And then we add 8 to both sides. Add 8, and x happens to be 14. X is equal to 14. Okay, properly written, x is equal to 14. There. All right, let's check and verify the answer. Watch the answer below the circle. There, you can see the answer over here. All right, so next is number 7. Let's continue with number 7. Let me clear the screen. Next diagram, number 7. All right, here's number 7. Find the measure of the arc or angle indicated. This time we're looking for an angle. The name of the angle is LJK. All right, where is that? LJK. It must be this angle here. All right. Or we will just mark it. Let's just put a mark. All right, this angle here. There. That's LJK. What should be the measure of that angle? All right, the way to do this is to get the measure of the arc first, this arc, and then half of that arc will be the measure of angle LJK. All right, so what do we have here? We have a diameter. This is a diameter, a chord which passes through the center, which divides the circle to half semicircle. So this will now be arc JK. Our working equation will be the measure of arc JK plus the measure of arc KL must be half circle. There, okay, that's 180 degrees. So we have two arcs added equivalent to half circle 180. Let's put the expressions. Arc JK is 18x plus 2. So this is 18x plus 2 plus arc KL, that's 11x plus 4. 11x plus 4. And this is equivalent to 180. All right, so we solve for x here. This will now be 29x. All right, 29x, combining like terms, 2 and 4 is 6, and this is equal to 180. Subtract the 6 from both sides, we get a 174. And this equates to 29x. All right, division now. 29x is equal to 174. We divide both sides by 29. All right, what do we get there? Is that a 6? Is that 6? 29 times 6 is 54, and 5, that's 17. Yeah, I'm checking by way of multiplication. Yes, it's a 6. X is equal to 6. All right, we're now ready to solve for the angle. All right, first we will get the arc. Okay, all right, let me clear the computation there. All right, so our formula to get the measure of LJK will be like this. The measure of angle LJK will be 1/2 of the measure of arc KL. There. And so this is 1/2 measure of arc KL will be 11x plus 4. 1/2 of 11x plus 4. 1/2 of that, which is 1/2 of 11 times x, 11 times 6 plus 4. And so we have here 66 plus 4, 1/2 of that. All right, that should be 70. 70 divided by 2, that's 35, okay? 35 degrees is the measure of the angle LJK. All right, that should be our computation. 35 degrees, is that 35 degrees? Let's check. Watch the answer below the diagram. Yes, it's 35. There, so this must be correct. Number 8 now, let's do number 8. Clear the screen. And we're now doing number 8. Next diagram is this. Find the measure of the arc or angle. We're solving for the angle. The angle VTS. So where's angle VTS? It's over here. There. That's angle VTS. All right, how do we approach the problem? We have one arc VR added to arc RS. That will be the subtended arc of the inscribed angle VTS, okay? This angle here. All right, so if we can only get those two arcs added and then divide by 2, that will be the measure of the required angle VTS, okay? So let's form our working equation. All right, the measure of angle VTS is equal to 1/2 of the arc, okay? 1/2 of the arc. Now, the arc VRS, okay, will be equivalent to the measure of arc VR plus the measure of arc RS. There. Okay, that two arcs added together will be the one piece arc that we need. Okay, and then we shall divide that by 2. That'll be the measure of the inscribed angle VTS. All right, so this is our working formula. Now let's put on the data that we have. The measure VTS is expressed as ATX. So this is ATX there. All right, that's the expression for the angle VTS. That's ATX. For the arc VR, that's 53x plus 1. So this is 53x plus 1. And then for the other arc RS, that's 106x. And then this is to be divided by 2, like that. And so we can combine like terms or start, or we can do it all together times 2 first. Okay, this is one piece. If we multiply by 2 right away, the left side becomes 160, okay, times 2. 80 times 2, that's 160x. So we will have something like 160x. And the right side of the equation will not have a fraction anymore, okay? And we will just combine 53 and 106. That should be 159, okay? 159x, and we still have the plus 1 there, okay? All right, I hope you were able to see my simplification there. After which we will now combine like terms by way of subtracting the 159. 159x minus 159x. And we now have just 160 minus 159 is 1. So we only have here 1x, or simply x. And the right side is just 1. Our x is 1, okay? And we can now compute for the angle. All right, we can now compute for the angle. Our required angle is the VTS. The measure of angle VTS is equal to 80x, okay? And this means 80 times 1, which simply gives us 80 as our answer. So the measure of angle VTS is 80 there. And so we shall check and verify from the computer. Watch the answer below the circle. There, it's 80 degrees. There, okay? All right, number 9 now. We're done with number 8. So we'll be moving to the next number 9. Number 9. All right, here's the next number. All right, here's number 9. We have the diagram. Solve for the angle GFH. GFH. We're looking for the measure of this. Okay. Now, the subtended arc by this inscribed angle is arc GH over here. And it has the measure 80x. Okay. 80x. So there. All right. So that means our working formula will be The measure of angle GFH is equal to 1/2 of arc, or 1/2 of the measure of arc GH. There, okay? 1/2 of the measure of arc GH. In an equation, the angle GFH is expressed 2 plus 39x, and this is 1/2 of 80x. There, okay? All right, so 80 divides by 2. So 80 divided by 2, this is now just 40x. This is 39x, and we have the 2 plus there. We subtract the 39x and subtract 39x. 40 minus 39 is 1, and we have 1x, that means x. And this is just equal to 2, or x is equal to 2. All right, we're not after x only, we're after the measure of the angle, GFH. And so the measure will be computed. This will now be the measure of the angle GFH expressed 2 plus 39x. Okay. All right, this will now be equal to 2 plus 39 times 2. This is now equal to 2 plus 78. Yes. And so 78 plus 2 is just 80. 80 degrees is the answer. This is the measure of GFH. All right, that gives us our final answer. Let us check and verify. There, you can see the answer below the diagram. It's 80. So this is the correct answer. Continue with the next number 10. Let's clear our solution. Proceed to number 10. You can always review the solution later. Number 10. Let's continue with number 10. All right, here's number 10. Okay, here's number 10. Find the measure of the arc or angle indicated. Now, we only have the question mark right here. And that means we're after this part of the circle. There, that particular arc. All right, so how do we go about the solution? Okay, we already have one inscribed angle. This angle here, that's 48. When doubled, that will be the measure of this arc ED. So that means 48 times 2 is 96. That will be our arc ED. There. Now, we have another given arc FE that's given at 150. There, okay? All right. Let me draw my arc properly. A little close to the circle. All right, this. All right, that is 150, okay? We have 150 and 96 plus the question mark that is going around the circle. We will equate that to one full circle, okay? And so we will have our working equation, the measure of FE plus the measure of computed arc ED. That's double of 48, that's why it's 96. All right, plus the unknown arc DF. That's one full circle. Okay, this is now easy. Our F is 150. Our ED is computed at 96. We're looking for the arc DF, the one with the question mark, and is equal to one full circle. Yeah. All right, so this is now how much? 246. 14, carry 1, that's, yes, 246. Plus the measure of arc DF is equal to 360. We now subtract the 246. We now subtract 246, and we have the measure of arc DF This is 4 and this is 1. Yes, it looks like 114 degrees. Okay, 114 degrees. All right, 360 minus 246. Yes, all right, let's check and verify. Watch the answer below the diagram. There, it's 114. And that's our answer also. All right, so number 11 now. Shall continue with number 11. Okay, here's number 11. All right, let's see the diagram first and do a little analysis. We're after a minor arc XY, okay? All right, so how do we approach the problem? We have a given inscribed angle here, and multiplying that measurement by 2 provides this arc here, okay? That means arc ZY is 80, there. And so 80 plus 122 plus the unknown is 360. So our working equation will now be just, all right, let's put our working equation. All right, let's start with the unknown. Arc XY plus arc YZ plus arc ZX must be 360 there. All right, so XY is unknown. YZ is computed 80. ZX is given 122. And this is one full circle. There. Okay, so this must be about 202. 80 plus 122 is 202. Yes, plus the unknown XY arc is equal to 360. We now deduct the 202 from both sides. This is minus 202. So this is 8, this is 5, and this is 1. Yes. Okay. The measure of arc XY. That will be 158 degrees. Yes. All right. That's our answer. Let's check and verify from the computer. Yes, it's 158. You can see the answer blinking below the diagram. Okay, that's 158 over there. All right, so that's also our answer. All right, let's continue with number 12. Let me clear the solution. Let's continue with the next number 12. All right, here's number 12 diagram. Let's do a little analysis here. We're looking for this arc. Yes. All right. So this is a little complicated. It's not really that complicated. We have a diameter over here. That means we can produce a 180. All right. Where is our 180? This is our 180. Also, this is 180 there. Okay. All right. So let me remove some of the arcs. All right. So we shall use the half circle XBV, okay, XBV. All right. We have the measure of arc XVB. That's half circle, 180 degrees. And this is equal to 2 arcs, okay? The measure of the unknown arc BX, all right? That arc BX plus arc BV, arc BV, all right, is equal to 180. All right, notice the arc BV over here. That's 2 times of the inscribed angle with a 47 there. So that means 2 times of 47 there. plus measure of the unknown bx, and this is equivalent to 180 there. All right, so we have the measure of arc bx, and this is now how much is that? 94. Will that be 94? So that's 14, and then yes, 94. This is equal to 180. All right, we subtract 94 from both sides. This will now be 6, and this is 17 minus 9. This is 86 degrees. That's the arc BX. There. All right, let's verify. Let us verify the answer. What's the answer below the diagram? Yes, it's 86 over here. There. All right, that's our computed value. All right, next number is 13. Let me proceed to number 13. Let me clear the screen. You can always check on the solutions later when you run the video. All right, let's clear number 12. Let's proceed to number 13. All right, next is 13. All right, here's number 13. This is only solved for x, okay? But then how do we go about the x? All right, let's do a little analysis of the drawing. Okay, one inscribed angle there, and it subtends the arc over here. So that means 93 times 2, okay? All right, so we have 186 for this arc here. 186, okay? Let me write my 186 clearly. There, it's 186. That arc that I made, all right, that arc KTS, which is twice the 93, okay? All right. Now we have one full circle now, the 186 plus the 72 plus the arc RS expressed 52x minus 2. We have the equation for 360. All right, let's start with the equation. All right, let's name our 186. That's our RKTS or STK. There, STK. All right, plus our KR. All right, plus one more arc, RS. All right, RS. That should be one full circle. All right. There. So don't forget the one full circle, 360. All right. STK is computed. That's 2 times 93. That's 186. And we have our KR arc. That's 72. That's given. And then our arc RS expression, algebraic expression, 52x minus 2. And this is equal to one full circle, 360. All right. And so we're after x here. So we shall combine like terms. So this is 258, 186, 186 plus 72 minus 2. Okay. So that looks like 258. Yes, 258 minus 2, that's 256. Let's do it over here. 186 plus 72. Added together, we have 258. All right. There's a negative 2 there. Okay. The other number is a minus 2. So we will subtract the 2. That means we have 256. All right. So combining all the numbers, 186, 72, and the negative 2, we have 256. And then we add the 52x. This equates to 360 there. All right, subtracting now the 256 from both sides. All right, there. And so we have just the left side is 52x. This is now 360 minus 256. This will be 4, 0, and 1, 104. All right, so division now, okay? All right, this is now 104 divided by 52. That looks like 2. 52x is equal to 104. Divide both sides by the 52. X is just a positive 2 there. And that's our x. All right. Let's check the answer from the diagram. You can see that below the circle. All right. That tiny number. All right. You can see it over here. That's the confirmation. This is the value of x. Number 14. Next number. Let's clear the screen. Continue with number 14. All right. Here's number 14. All right. Next diagram. All right, we have another problem here. Okay, so how do we go about the solution? If we will analyze the problem, we have the big arc here plus this arc is one full circle, okay? All right, and so this is the inscribed angle. 2 times of that will be the arc 2 times 8x minus 4 is this arc here, all right? So we shall call that arc WX, okay? Plus the arc XY plus the arc WY must be one full circle there. All right, so we can express the arc WX 2 times 8x minus 4. Remember, 2 times the inscribed angle measurement will be the measure of the subtended arc, okay? All right, and so 2 times 8x minus 4 is that WX arc. Now, it will be right here. So 2 times 8x minus 4 plus our arc XY, which is 4x plus 16, 4x plus 16 plus our arc WY, which is 8x minus 12, and that is one full circle there. All right, solve for x. Okay, so everything divisible by 2, right? Everything divisible by 2. If we divide this by 2, we divide this by 2, we divide this by 2, and divide this by 2. We will have smaller numbers. All right, and so this cancels out. We only have 8x minus 4. There, okay? And 4x divided by 2 is 2x. 16 divided by 2 is 8. 8x divided by 2 is 4x. 12 divided by 2 is 6. Equals 360 divided by 2, that's 180. All right, we have smaller numbers now. All right, let's combine like terms. We can still further divide by 2. Still, they are divisible by 2. All right. Yes, we should have divided by 4. All right, but then we will have a complication here with the parentheses. Okay. All right, so we shall divide by. All right, let's minimize the numbers again. Let's divide once more. So let's divide everything by 2 there. Okay, this will have 8 by 2 is 4x. 4 by 2 is 2. 2x by 2 is just x. 8 by 2 is 4. All right, 4 by 2 is 2x. 6 by 2 is 3. 180 divided by 2 is 90. That's it. We now have smaller coefficients. We can combine like terms. We now have 4x plus 2x. That looks like 7x. All right, 4 and 1, 5, and the 7x. Yes, we're done with the x values. We now have the numbers 4 and -2 and -3. That looks like -1. Okay, +2, yes, and -1. So that's a 5 and a 4. 5 is greater, so it's a -1 equals 90. Okay, proceed by addition, add 1. And then add 1, we have 91 equals 7x. All right, so we continue by way of division. This is now 7x is equal to 91. We divide by 7, divide by 7. X must be equal to 13. Yes, x is equal to 13. Let me rewrite my number 3. Okay. All right. Let me rewrite my number 3. There. All right. So x is equal to 13. Is it? All right. Let's check and verify. See the answer below the diagram? Yes, it's 13. Yes, down there. It's blinking. All right, there. So this is 13. That's our x. All right, let's proceed to the next number 15. Let's clear our solution. Proceed to number 15. Okay, here's number 15. All right, so from the diagram, it looks like we have two expressions there, and it looks like we're solving for this angle, and that angle must be compared. All right, that looks like a vertical angle pair, so that means they are equal. Okay, they are equal, and so our working equation here will just be -2 plus 5x must be equal to 4x plus 9, like that, and we shall solve for x here. That's the requirement. Solve for x, and so we shall add 2 first to both sides, and we have 5x at the left side. The right side is now 4x plus 11. We shall now deduct the 4x and deduct the 4x, and x is found 11 there, and that's it. It's the required x. Solve for x. Let's verify the answer. Is it 11? Yes, it's 11. All right, there. So that's correct. Number 16. Let's continue with the next number. Let's clear the screen. Proceed to the next number. Number 16. Oh, it's the last number. Okay. Oh, no. We have number 16. Let me rewind. That was our last number. Our next number must be 16. There. That should be it. This is it. All right. I thought 15 is the last number. We still have number 16 over here. Find the measure of the arc. Okay. Arc WV. All right. Where is WV? There. That arc there. All right. This is rather simple. These are all arcs. Okay. These are all arcs. So that means this arc WV plus the VX plus the XW is one full circle. So we will have our working equation, all arcs. So let's start with the unknown. Arc WV plus the measure of the next arc VX plus the next arc XW must be one full circle. This is our working equation. All right, so WV is expressed 12x minus 2. So 12x minus 2 plus arc VX will be 7x minus 14. 7x minus 14. Plus the next arc xw, that's 7x plus 12. And this is equal to 361 full circle. All right, solve for x first, okay? And then we will use the 12x minus 2 for the WV. All right, so we will have to do the x first. All right, combine like terms. 12x plus 7x plus 7x. That looks like 26x. Okay, a 14. Yes, that should be 26x. All right, all x combined. How about negative 2, negative 14, and the positive 12? So that will be negative 16 plus 12. That's a negative 4. Okay. All right. So that's a negative 4. Combining the negative 2, the negative 14, and the plus 12. So that's a negative 4. We're done with the left side. The right side is just 360. All right. Add 4 to both sides. We have the right side at 364. And is equal to 26x. All right. So next step is to divide both sides by the 26. So we divide by the 26, divide by the 26. All right, let's do our division. 364, we divide this by 26. We have 1, 26, 1, 0, 4. We have about 4. 24 and 2, that's, yes, remainder 0. So our x is 14. Okay, we do not stop with x equals 14. We're after the measure of the arc, WV. All right, WV is 12x minus 2. This arc here. Okay, this arc here. All right, so we shall remove our division here, and we will use it for our solution. Okay, our solution for arc WV. All right. Our measure for arc WV is equal to 12x minus 2. So we shall have here 12x is 12 times 14 minus 2. There. Okay. And how much is that? So 12. All right, let's do it over here. 12 and 14. So this is, okay, what do we have there? 12 times 14. That looks like, how much is that? 12 times 14. That looks very large. Okay. WV. 364 by 26. Is our division correct? Let me do a little review there. 12 and that's 26. Yeah, that looks correct. But then negative 14. All right, let's go back there. That looks like 28 and 14. That's only 168, right? 168, yeah. All right, so 168, that looks correct. All right, looks correct. All right, so that'll be 28 and 14, that's 168. So this is a product of 168 minus 2. That's only 166. Yes, all right, so this is the measure of our arc, WV. I thought it's very, very large, okay? I was looking at 14 times 26, it returns to 364, okay? But we're actually doing 14 times 12 only. All right, so that will only be 168. So 168 minus 2, it's 166. All right, so that should be it. All right, my computation is 166. All right, let's determine the computer's answer. Let's check and verify. Look at the diagram below the circle. Yes, it's 166 over here. There. Okay. All right. That looks correct. Okay. Next number is 17. Let's continue with the next number. Clear the solution. Clear the answer. Proceed to number 17. All right, here's number 17. Find the measure of the arc EF. Where is that arc first? All right, it's over here. There. We're after that, okay? Now we have the inscribed angle over here. Okay, we shall use a straight lines. All right, this and this forms the inscribed angle, which is the 4x. All right, this is the subtended arc by the angle at point G, the inscribed angle, which is expressed 4x. All right, the relationship goes like this. The angle EGF, the inscribed angle, EGF, all right, that angle is 1/2 of the subtended arc EF. Yes, okay, 1/2 of that, right? All right, 1/2 of that arc is the angle EGF. All right, and so we can now put the algebraic expression 4x, which is equal to 1/2 of EF is 9x minus 12. Okay, so this is 9x minus 12. There, all right. Okay, get rid of the fraction first. So we will have 4x equals to 1/2 9x minus 12. Multiply both sides by 2 and by 2. Okay, this cancels out. We have 8x is equal to 9x minus 12. Yeah. Okay, subtracting now the 9x from both sides, we'll have negative 1x is equal to negative 12, or x is simply positive 12. There, all right. And so we're after the arc, okay, not the angle. So arc EF, this is now expressed 9x minus 12. The measure of the arc EF is equal to 9x minus 12. Our x is 12, so we have 9 times 12 minus 12. All right, so this is a 12, right? So 9 times 12, how much is that? That's 108 minus 12, so this will be, how much is that? 96. 8 minus 2, 6, 10 minus 1, that looks like 96. The measure of arc EF, there. Because the one inside is 48, okay? The inscribed angle is 4x, so that's 4 times 12, that's 48. Times 2, that's 96. Yeah, that's a little check. All right, so we're after the arc, not the angle. So our answer is 96 degrees. All right, and let's check and verify. Look at the diagram below. Yes, it's 96 degrees. There. The answer from the computer is 96, which is also our computed answer. All right. Next number 18. Clear the screen. Number 18 over here. All right. That looks like the last one. Yes, that looks like the last one. All right. So what do we have here? Find the measure of the arc QP. All right. And this arc QP must be this arc here. And we have 3 arcs here. Okay. We have 3 arcs. This arc and this arc and the unknown arc QP there. All right. So we will just go around the circle, add these 3 arcs equals 1 full circle. Okay. All right. So let's put our working formula. The measure of arc QP plus the measure of arc PR plus the measure of arc RQ must be equal to 1 full circle, 360. All right. Our QP is given 7x minus 15. Our PR is 11x minus 5. 11x minus 5. Our RQ is 7x plus 5. 7x plus 5. This is one full circle, 360. So first we will get the x, and then use the expression for QP. All right, so add the x first. 7 plus 11 plus 7, that's 14. That must be about 14 plus 11. So that's 25x. Yes, that's 25x. All right, so how about the numbers? This number 5 and this number 5 cancels to 0. We will only have the minus 15. There. For a simpler, shorter solution, adding all the numbers results to minus 15. The right side is just 360. All right, there. All right, so we proceed by addition. Add 15. Add 15. This will now be 25x. And this is equal to 375. And proceed by division. We have 25x equals 375. We divide both sides by 25. How much is that? 4, 4, 4, 12. We have x equals, how much is that? That looks like 15. Yes, 15. X is 15. All right, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. X is equal to 15. We're after the arc. Solve for arc MQP. All right, with expression 7x minus 15. So this is 7 times the 15 minus the 15. So this looks like 105. 105 minus 15. And so this is 0 and 9. Yes. 5 minus 5, 0. 10 minus 1, 90. Is that 90? Will that be 90 degrees? Let's check and verify. Measure of QP. Our answer is 90. Okay. Our answer is 90. All right. So let's check and verify. All right. 90 degrees. Is it 90 degrees? Yes, it's 90 degrees. All right, there. Confirmation by the computer. Our answer is 90 degrees. And that'll be it. This is our last number for measure of inscribed angles. And yes. All right, so that's it for inscribed angles. We will discuss more later, and see you later. God bless you.